Okay, so this is the second exam or test question you will see. Are you getting it? Now, look at this one. So you can see that this one is very different from the previous ones. Abi. We are going to we are moving to more complex ones, but it's very simple. Listen carefully. They said use the method of dimension to choose the correct equation below. Use the method of dimension to choose the correct equation below. These are the given options. So meaning we have to choose the correct option. Okay. Option A, V equal to U plus AT, B, V equal to U plus ST, C, V equal to A plus T, then D, V equal to UT, UT plus A, UT plus A. Are you getting it? Now the question is what is the correct answer or what is the correct option? Now take note, this type of dimension, what they are asking you now, this is the rule behind this type of question. Look at it. This V, in the study of motion, there is something we call initial velocity and final velocity, right? V stands for final velocity. If you want to write it down now. V stands for final velocity, final velocity, while U stands for initial velocity, initial, 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 initial velocity. Then A stands for acceleration, right? Then T stands for time, S stands for distance. Okay. Now look at this. Look at this equal sign. Look at this equal sign. Okay, if someone said you and your friend, you guys are equal in height, meaning that you and your friend, you guys have what equal height, right? Equal height. Now look at this one. They said V equal to everything here. In mathematics, this one stands for equal sign now, equal to, isn't it? Meaning that this one is equal to this one, isn't it? So, meaning that the dimension of final velocity must be equal or must be the same, must be what? Similar, all of them are the same thing, must be the same with the dimension of this initial velocity and the dimension of these two quantities. Are you getting it? So meaning that after solving, if the dimension of this one is different from this one, meaning that after solving, if the dimension of this one is different from this one's, meaning the answer is incorrect, it's not correct. Are you getting me? But in a situation where after solving, the dimension of this first one is the same, all of them are the same, all of them are the same. Are you getting it? Meaning that answer is what? The correct one. Are you getting it now? So let's solve, okay? So we can, so if you see this type of question, you have to be very fast in solving. So let's start from the first one, which is V equal to U plus AT. So meaning that after solving, the dimension of this one, that is what you will have here. That is what you will have here. If peradventure the dimension of this one is different from this one, that is wrong. Meaning for it to be dimensionally correct, all the dimensions must be the same. Okay, so let's start from this one. Now take note, initial velocity, final velocity, all of them have the same dimension because all are the same thing as what? Velocity, isn't it? It's all the name, initial starting point, final the final point. But like the first one we did, potential energy, kinetic energy, are they not the same things? They are the same things, they have the same dimension. So applicable this into these two. Okay, all these are velocities, final velocity, initial velocity. We solve for the dimension of velocity, right? Which is what? LT, if you check your book, LT raised to minus 1, right? This is the dimension of velocity. The same thing, this one too, the dimension of what? Velocity, right? So meaning that we've gotten what two dimensions, meaning this one is what the same with this one, isn't it? Don't be confused with these two words. Final velocity, initial velocity, all of them are still the same. They contain the same dimension, meaning that all of them are what um this thing velocities. Are you getting it? So this one is the same thing as this one. Are you getting it? So now we are left with now you are left with this AT, which is acceleration and time. And we've solved for the dimension of acceleration, isn't it? Yes. We've solved for the dimension of acceleration, which is L c raised to what? -2, right? Check your book. All these are in your notes. We've solved for all these things before. So you don't expect me to be breaking down everything again. No. That's why I said when you come across this type of questions, you have to know their dimensions so you can solve questions more easily and faster because you are working with time. I get it. You are working with time. Okay. So now this is a dimension of acceleration. Are you getting it? This is the dimension of acceleration. Why? The dimension of time is what? Is not t. It's only t now, isn't it? Okay. Now let's bring everything here. Let's apply the law of indices in this place. We have only one L, Abi. We have only one L now, but we have two time here. Okay, let's solve for these two. We have t raised to -2 times t. Let's solve for this 2t. I get me. So we come up with a single t. Okay. Now, from one of the laws of indices, it states that, listen, no, it states that if the two bases, bases are the down numbers or the down alphabet, these down ones can be in number form or in alphabet. What is ABC? Are you getting it? So one of the laws of indices, that is the multiplication law. If the two bases or the two down alphabets are the same and the middle is multiplication, meaning that you will add the exponent. The exponent is talking about the upper numbers. Are you getting it? Exponent is talking about the upper numbers. I repeat, one of the laws of indices states that if the two base numbers or the two base alphabets they are the same or similar, you can notice that T and T are the same things now, isn't it? T and T are the same. And the middle is multiplication. Take note. What you do is you take only one base. Take only one base, and if the middle is multiplication, you add the upper numbers. Are you getting it? And take note, any single number or single alphabet that is standing alone, it contains one on top. Any single number like 2 here, it contains one on top. Even as a mathematician, are you getting it? So you have to understand this because any number raised to power 1 is still that particular number. 100 raised to power 1 is still 100. 1000 raised to power 1 is still 1000. Any number raised to or any alphabet raised to power 1 is still the same that alphabet or number. So please take note. Now, I said if the two base alphabets or numbers are the same or similar, you note that T and T are the same things, right? You take only one T since they are the same. T and T are the same things now. You take only one T. Since take note of the middle. Since the middle is multiplication, if the middle is multiplication, you what add the up numbers. So it will now be what -2 this here, then add them plus this one. Are you getting it? There is -2 here, so it doesn't mean you will remove this -2. No, you add it. Are you getting it? The middle will be addition since the middle is what multiplication. Are you getting it? If the middle is multiplication, you will add the up numbers. Are you getting the explanation now? So -2 plus 1 is what? minus 2 plus 1 is what? Is minus 1. So it will now be t raised to minus 1. Are you getting it? So take note, we still have L here. So it will now be L t raised to minus 1. Are you getting it now? Lt raised to minus 1. Now look at it. We have Lt raised to minus 1, Lt raised to minus 1, Lt raised to minus 1, meaning this one is correct. They said use the method of dimension to choose the correct equation below. So I said since this v is equal to this one, so mean that all the dimensions you'll be solving, all of them must carry what? Equal dimension or the same dimension. So if peradventure we have different dimensions, meaning that particular equation or formula is dimensionally incorrect. But from our solving, we've noticed that this particular one is what? Is correct, right? So this one is correct. This is it. So since you are solving for exam, since you are solving exam question, you are in exam period. So meaning that once you get the first one, you just mark it and move to the second question. I get it, because meaning that if you solve for the rest questions, you will get wrong answer. Let's try the second one. So from the first question is what? Dimensionally correct, right? Meaning that all these rest ones will be what? Dimensionally wrong, because after solving, you will see that one of these ones will contain a different dimension. Let's solve it. The first one is what? The dimension of velocity is still the same, like Lt raised to minus 1, abi? The second one is still the same thing, Lt raised to minus 1. We are left with St. S stand for what? Distance. I've told you guys before, S stand for distance. St. St. Now, distance is still the same thing as what? Length, abi? Length. They are put through LMT. Distance is still the same thing as length. So L. The dimension of time is what? Is T. So this is what we have, plus LT. Are you getting it now? So from this one, these two are the same, Lt raised to minus 1, Lt raised to minus 1, but this one is different, only Lt. So meaning that this particular one is different from this one. So any one that contain a different dimension, meaning the whole of that equation is wrong, is dimensionally incorrect. So this one is bad. So even if you solve for this one, it will still give you a wrong dimension. Now look at it. V, the third one, V equal to A plus T, right? A plus T. The dimension of velocity is what? L T raised to minus 1 plus, sorry, equal to, the dimension of acceleration is what? We've solved for it before. It is L T raised to what? Negative 2 plus, the dimension of time is what? Is T, which is T. And look at it. Are they the same? No. All are different, so meaning this one too is bad. So you can try this one out. You can try this one. After solving, you will notice that the dimensions, all the dimensions will contain different. So meaning that even if two of them contain the same dimension, if one of them contain a different dimension, means that equation is wrong. Are you getting it? So the correct answer is option A. All these are exam and test questions you will see. Are you getting it? All these are test and exam questions you will see. So the correct answer is option A. In case you don't understand, you can rewatch, wind back and rewatch it again. But I know this detailed explanation. So meaning if you see this type of question, meaning that this first one must be, if this first quantity is distance, meaning that like just take note, this equal sign mean that all of them must carry equal dimension.